Hey guys, so today I want to talk about something called acids. Specifically, we're mainly going to focus on naming these acids, and writing the formulas for them. But we have to kind of discuss what an acid is first off. So this first example here, this is an acid. HCl is technically I acid. If you look at it, hydrogen and chlorine, they're both non-metal. This, if I decide ionic or molecular, it is in fact molecular. So we should call it by the molecular names hydrogen monochloride. Okay, and this would be its dot structure, and it is a molecule. Hydrogen monochloride is actually a gas, it floats around in the air. But the thing is, acids are molecules, but when they react with water, like when you get water near them, something weird happens. They actually act like something that's ionic, even though they are molecular. And by act like ionic, I mean they will split apart into two ions. So it is a molecule that normally, just as itself, is a molecule, but when mixed with water, and only when mixed with water, it will actually do something called dissociate, and it will break into two ions, even though it's a molecule. So here is a beaker filled with hydrogen monochloride, the molecule, okay, floating around as little molecules. But add water to it, and that water will actually break it apart into hydrogen ions, which has a +1 charge, and chlorine ions, which has a -1 charge. Okay, so this is essentially what an acid is. An acid is something that is molecular, it's a molecule, but when you add water to it, it breaks into two ions, and one of those ions is always hydrogen with a +1. Okay, with acids, you always get the same positive ion. So anytime you come across something that has hydrogen written first, that's an acid. The reason we're writing it first is because we want to indicate it's an acid. Okay, it ionizes with water and it's going to break into two ions, H plus and whatever the other part of it is. Okay. Now there are some molecules that have hydrogen on them that do not do this. For example, CH4. But when we write CH4, we write it CH4 with the carbon first to indicate that those hydrogens at the end are not going to do this. But when we want to indicate that it will do this, we would then write the hydrogen first. Kind of like we write a positive first when we write an ionic compound. Since the positive in this breaking apart is always hydrogen with a +1, we write that hydrogen first to indicate it. Okay? So treat these kind of like ionic compounds, where it's always hydrogen as a +1 that is the positive. Okay? For example, a binary acid. Binary means two elements. It's always going to be hydrogen and another element. Hydrogen's the positive one, the other element's the negative one. So if we have, say, hydrogen with a +1 and Cl with a -1, we get HCl. If we have hydrogen with a +1 and phosphorus, which has a -3, we don't get HP, we get H3P. You get three hydrogens, because they're +1, to every one -3 of the phosphorus. All right? Hydrogen with a +1 to bromine, which is a -1, well, that's equal charges there, so HBr. Okay? So on and so forth. Those are called binary, where we have hydrogen with an element. All right. Now, these names, when we name them, they have a special name. Instead of calling them like hydrogen phosphide or hydrogen monophosphorus or something like that, we're actually going to call them an acid name. Now, there's different rules for naming an acid. Binary acids, like this, and hydrogen with an element, the rules are, okay, the hydrogen with one other element, we're going to use the prefix hydro. Okay? Hydro does not mean hydrogen. It actually refers to the fact that it's mixed with water. All right? But I want to emphasize that hydro is about binary acids. We're going to get to non-binary acids in a minute, and they won't have hydro. It's just hydro is a binary acid. Now, you're going to use the root of the anion, the negative one, okay, and then change its ending to ic. Okay, so instead of "ide," it's "ic." All right, so then we just add the word acid to the end. So if I kind of go back to this slide here, this first one here, we have HCl. So we have hydrogen with chlorine, okay, which we call chloride. So we're going to change this hydrogen chloride. We add hydro to it because it's a binary acid. Chlorine, change the ending to ic, chloric acid, hydrochloric acid. Hydrochloric acid. This next one here, we have hydrogen with phosphorus. So hydro, then phosphorus, change the ending to ic, so phosphoric, hydrophosphoric acid. Last one here, hydrogen and bromine, okay? Prefix hydro in binary acid. Bromine, change it to bromic, hydrobromic acid. Use the prefix hydro. Whatever the heck that negative part is, that's what we're calling it, okay? But we have prefix hydro in front of it. Change the ending of that negative part, that anion, to ic, end with the word acid. Okay, so if you come across a name that has the word acid in it, it's an acid right away. You know it's an acid, so it's going to have hydrogen for the positive, and then you kind of figure out what the negative is to figure out the formula. Okay, so this two examples here. This first one, I want you to actually try it here. So pause the video. What would this be called? Okay, so what would it be called? Hydro, first off. That's fluorine, so change it to fluoric acid. Hydrofluoric acid. Right? Hydrofluoric acid. Now, going backwards, we have hydrosulfuric acid. Hydrosulfuric acid. So this is going to be hydrogen with sulfur. Hydrogen with sulfur. The hydro means it's binary. Okay? So give this one a try. What do you think the formula of hydrosulfuric acid is? So hydrogen, which is a +1, and sulfur, which is a -2, we're going to get H2S. Hydrosulfuric acid is H2S. Okay? Now this is binary acids. Binary means hydrogen with one other element. So there's two elements here. We also have hydrogen with some of those polyatomic ions. Okay? So we can also have an acid that way. These are called oxyacids. Okay? Oxyacids. They're exactly the same as what we just talked about. It's hydrogen as a positive, and one of those oxyacids as, one of those polyatomic ions as a negative. Okay, and so they come together, forming a molecule that, when you mix with water, is going to break into two separate ions. So this first one here, we have hydrogen paired with the chlorate polyatomic ion, ClO3. That's a -1 charge, a +1, so this is going to be HClO3, one hydrogen, one chlorate. Okay, we call it chloric acid. Hydrogen with chlorite, ClO2. Okay, that's a -1, and this is a +1, so one of each again. This would be HClO2. We would call this chlorous acid. H with a +1 with a sulfate. Now this is SO4. It's got a -2 charge. So in this case, we would need two of the hydrogens, two of the +1s, to pair with that -2 of the sulfate. So this would be H2SO4. We'd call it sulfuric acid. Hydrogen with sulfite, also with a -2, but this time it's an SO3 is the formula. So still need two hydrogens, so it would be H2SO3. We call that sulfurous acid. Now, what you may notice about these names, first off, the part hydro is not a part of it. Okay? Hydro is not a part of these names. If hydro is part of the name, it's a binary acid. That means hydrogen with an element. If hydro is not a part of the name, that means it is an oxyacid. So it is hydrogen with a polyatomic ion. Okay? Hydrogen, polyatomic ion. No hydro written in the name. All right? So, naming these oxyacids, hydrogen with one of those polyatomic negative anions, use the root word of the anion, the -1, for the acid name. Okay, like chloric, or chlorate, chlorite, sulfate, sulfite. Okay? You're going to change the ending of that root word to either ic or os. If it is something that is ending in ate, like sulfate, nitrate, chlorate, then you change it to ic. So nitrate becomes nitric. Chlorate becomes chloric. Okay? Sulfate becomes sulfuric. You kind of got to add a little bit of the sulfur back in there for some reason. I don't know why. But sulfate becomes sulfuric. Okay, it's going to end in ic if the polyatomic ion ended in ate. If it ends in ite, then you're going to change that ending to ose. So nitrite becomes nitrous. Sulfite becomes sulfurous. All right? Chlorite becomes chlorous. Okay? So you change the ending to either ic or ose. And then you add the word acid. So here are some examples of this. HNO3. First off, it's hydrogen with a polyatomic anion, a negative ion. So in this case, if I just knock off the hydrogen, we're talking about an NO3, and it has a negative 1 charge. You go ahead and look that up on your common ion sheet. It's a polyatomic ion. That is nitrate. Okay? Nitrate. So since it ends in ATE, we're going to change that ending from ATE to IC, nitric. And then we're going to add the word acid. It's called nitric acid. Now, remember, hydro is only for binary acids, so we're not going to call it hydronitric acid. It's just nitric acid. The fact that it doesn't have hydro there doesn't mean it's not an acid, doesn't mean it's not mixed with water, doesn't mean it doesn't have hydrogen. Okay? The fact that it doesn't have hydro as part of the name just means that it's not hydrogen with an element. Hydrogen with an element, we use hydro. Hydrogen with a polyatomic ion, we don't. Okay? So this next one, chlorous acid, chlorous. Now, because this is chlorous, what that means is we're looking for the anion that ends in ite. So we are looking for the anion called chlorite. Okay? Chlorite. Now I look up what chlorite is. It is ClO2. It has a negative 1 charge. So pair that with hydrogen. The formula for this would be HClO2. HClO2. Let's do a few more examples. Okay, so this first one here, it's hydrogen with a PO4. Now, first off, this is not a binary. This is one of the oxyacids. So this is oxyacid rules. Okay? Helpful to identify it as either oxyacid or binary first. Which type of acid are we talking about? So oxyacid means we are dealing with one of those polyatomic ions. In this case, the PO4. That PO4 is called phosphate. It ends in 8. You look it up on the common ion sheet. All right, it is PO4 right there, negative 3 charge. It's called phosphate. Okay? And it's with hydrogen. Now, it is not a binary, so don't use hydro. It's just phosphate. We're just going to name it after that phosphate. So here we go. We're going to change the ending of phosphate to ic. So we're going to call it Oops, I forgot the S. Phosphoric. And we're going to add the word acid. So this is called phosphoric acid. Next one, we're going backwards. Sulfurous acid. It ends in us. It does not have the word hydro there. So this is actually another oxyacid. Okay, that means a polyatomic ion. It ends in us. So really, we are looking for an ite. So sulfite is what we're looking for. So I find sulfite right here. Okay, since it ends in us, ite. Sulfite is SO3. It's got a negative 2 charge. All right, so we've got SO3 with a negative 2 charge. Paired with hydrogen, which is a +1. I'm going to need 2 hydrogens here. So our formula for this would be H2SO3, sulfurous acid. Okay. Next one, HI. It's an acid. Okay, we're going to name it here. This is binary. It is a hydrogen with an element. Okay, so since it's binary, we're naming it after that element, and we're putting hydro in front of it. So we're going to start with hydro. because it's binary. Then we're going to figure out what element it is. That is iodine. Change the ending of iodine to ic. So iodic, hydroiodic acid. Answer is hydroiodic acid. Okay? This one here, we have hydrogen, and then we have a polyatomic ion. So this is an oxyacid. This polyatomic ion, NO2, look it up here. NO2, right there, it's got a -1 charge. It is nitrite. So we call it nitrite. Since it ends in ite, we're going to change that to ose. We are not going to put the word hydro there. Okay? It's not a binary. So we're going to call it nitrous acid. Nitrous acid. Okay? Acetic acid. Okay, the word hydro is not here, so this is a oxyacid. So it's one of the polyatomic ions. It ends in ic, so we're going to basically look for something that ends in ate. All right? So acetate is what we're looking for. Acetate is right here. It is C2H3O2. It's got a -1 charge. So we have C2H3O2, -1. It's paired with hydrogen because it's an acid. It's +1. That's +1, -1. So the formula is HC2H3O2. Now notice that I want to keep this acetate together, C2H3O2. So even though I have 4 hydrogens here, this H3 is part of the acetate ion, and then the H here is part of the fact that it's an acid. So only this H is going to break off when it gets in water and breaks into pieces. All right? Hydrobromic acid. Hydro means binary. So we are dealing with hydrogen plus an element. Which element? Bromic. Well, bromine. Bromine. So change the ending from ic to, it's an element, bromine. So bromine, Br, which is a -1. Same charge, +1, -1, so this would be HBr. Okay? This next one here, HClO. HClO. Well, that is my polyatomic ion, so this is an oxyacid. Okay? It's got hydrogen with it, but it's a polyatomic ion, so we're looking for ClO, which is a -1. We have ClO2, which is chlorite. So one less than that would be hypochlorite. Okay, so this right here is hypochlorite. Not hydro, hypochlorite. Okay, so what we would call this acid, we're going to change the ite to ose. So we're going to change it to hypochlorous acid. This is called hypochlorous acid. Periodic acid. Periodic. The per means one more oxygen than iodic, which in this case it would be iodate. This is an oxyacid. Okay, no hydro. So oxyacid. Since it ends in ic, we're going to look for 8. We're looking for periodate. Periodate, one more oxygen than iodate. So iodate is IO3 with a -1, so one more oxygen than that will be IO4 with a -1. Paired with hydrogen, +1, this gets me HiO4. Periodic acid is HiO4. Okay, last one, H2CO3. That is in polyatomic ion, so this is an oxyacid, so we're not going to use hydro. Okay, we're going to name it after this polyatomic ion. This would be CO3 with a -2 charge. We call that carbonate. When you look it up, since it ends in 8, we're going to change that to ic. So this is called carbonic acid. That is how you name and write formulas for acids.